The scene. Batman is seen flying very fast in the Bat over what appears to be the Long Island Sound, with a nuclear bomb in tow. The bomb is rapidly decaying as he flies out, and eventually explodes. Assuming he was somehow able to get rid of the bomb and abandon ship, could he have survived the massive explosion that ensued?
You too. Come on, Father. Hey, heads down! This is it!
No! That's Batman!
That's detonation. It's out over the bay. It's clear of the city.
Batman's Batplane is a combination of the Harrier jump jet, the Bell Boeing V-22 Osprey, and the Boeing AH-64 Apache helicopter. The jump jet's top speed is 737 miles an hour for the Sea Harrier FA-2 model. The V-22 Osprey's top speed is 351 miles an hour, and the AH-64 Apache's top speed is 182 miles an hour. But it's Batman, and it isn't ridiculous to imagine the Batplane flying at speeds at over 1,000 miles per hour. However, in the scene, the Batplane isn't seen breaking the sound barrier, meaning there's a cap on his speed at the speed of sound, 343 meters per second. The bomb that the Batplane is carrying is a fusion reactor core nuclear bomb. It has a 6-mile blast radius according to Russian nuclear scientist Dr. Leonid Pavel. It is a 4-megaton bomb, which is equivalent to 4 million tons of TNT exploding. It is close in the blast yield to a double W-38 nuclear warhead, which weighed about 3,000 pounds. When Batman jumps from the Batplane, he's falling in the y-axis quite fast. He's falling a distance of about 10 meters, or 30 feet, and he's accelerating at 9.8 meters per second squared. We can find the velocity that he's falling towards the water with by using the formula the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the distance. It simplifies to show us that his final velocity is 14 meters per second, which is about 31 miles per hour. Professional divers fall from heights much greater, with a world record of over 170 feet for a high dive. Batman has a high enough skill set to survive just a 30-foot fall, falling at about 14 meters per second, so this is not a problem in his survival. However, what does become a problem is when he is falling from the Batplane, he's also traveling in the x-axis. It takes him a grand total of 1.4 seconds to reach the water from the Batplane. And in that 1.4 seconds, he travels 480 meters in the x-axis towards the bomb. Since it's just over 5 seconds the last time we see Batman actually inside the Batplane, we can assume it's about 5.5 seconds. So using the distance equals velocity times time formula, we can find that the Batplane only travels about 1,886 meters during the time he is not in it. That's about 1.17 miles. As he is falling towards the bomb, he travels about a third of a mile towards it, which puts him about 0.87 miles away when the bomb finally explodes. This drastically decreases his chances for survival, as 0.87 miles will not put him outside the blast radius of 6 miles. In a book written in 1995 by Paul Zitzowitz and Robert Neff, they stated that the temperature near the center of an atomic bomb would be about 1 million degrees Kelvin, which is about 1.8 million degrees Fahrenheit. That's about 172 times hotter than the surface of the sun, which is a chilly 5,800 degrees Kelvin in comparison. Batman's suit in the movie is made of Kevlar, according to a scene earlier in the movie, so that it can stop bullets. Kevlar has no melting point, but it starts to deteriorate at about 500 degrees Celsius. At the temperature of almost 1 million degrees Celsius, it will render this suit almost useless. Additionally, the suit could heat up so hot that it would start to burn him. Finally, not 100% of Batman's body is covered in Kevlar, so there's just no possible way he's escaping being burned, in addition to being within the 6-mile blast radius. In conclusion, there's no way Batman could have survived this explosion. It's nothing but a big myth in another Hollywood movie. Barkin Watson out.